Article 406.12 of the National Electrical Code states that outdoor receptacle outlets that are not part of a building shall be protected by a ground fault circuit interrupter, or GFCI. This requirement applies to all outdoor receptacles, regardless of whether they are used for lighting or other purposes. Article 210.12 of the NEC states that general-purpose branch circuit shall be protected by an AFCI circuit breaker when installed in a dwelling unit. This requirement does not apply to outdoor circuits unless they are part of a dwelling unit. The Nevada State Electrical Code adopts the NEC with some local amendments. However, none of these amendments affect the requirements for GFCIs or AFCIs in outdoor locations. Based on the NEC and the Nevada State Electrical Code, an installation is not acceptable if it uses an AFCI breaker instead of a GFCI breaker for outdoor receptacles. Outdoor receptacles, including those on a patio, must be protected by a GFCI. An AFCI breaker, while providing protection against arc faults, does not provide the same level of shock protection as a GFCI. A GFCI, or ground fault circuit interrupter, detects small imbalances in electrical current and trips the circuit if a ground fault occurs, protecting people from electrical shock. An AFCI, or arc fault circuit interrupter, detects dangerous electrical arcing and trips the circuit to prevent electrical fires. While AFCIs offer protection against electrical fires, they are not a substitute for GFCIs, which provide protection against electrical shock. Both types of devices are important for ensuring electrical safety in different situations. The electrician should replace the AFCI breaker with a GFCI breaker for the outdoor patio circuit to comply with code and ensure electrical safety. To elaborate further, let's delve deeper into the functions and applications of both GFCI and AFCI circuit breakers. Understanding their distinct roles is crucial for ensuring comprehensive electrical safety. Ground fault circuit interrupters, or GFCIs, are designed to protect individuals from electrical shock. They operate by monitoring the balance of current flowing through a circuit. In a normal circuit, the current flowing to an appliance or device should equal the current returning. A GFCI constantly measures this balance. If there is a difference of as little as 5 mA, the GFCI will trip the circuit, cutting off power almost instantaneously. This happens because the imbalance indicates that current is leaking potentially through a person who is inadvertently providing a path to ground. This leakage is known as a ground fault. Common scenarios where ground faults occur include touching a live wire while also being in contact with a grounded object, such as a metal water pipe or a damp surface. GFCIs are particularly important in areas where water is present, as water significantly increases the risk of electrical shock. Therefore, the NEC mandates GFCI protection in locations such as bathrooms, kitchens, laundry rooms, garages, and, as previously mentioned, outdoor receptacles. The installation of GFCIs in these areas significantly reduces the risk of serious injury or death due to electrical shock. Arc fault circuit interrupters, or AFCIs, on the other hand, are designed to prevent electrical fires. They detect dangerous electrical arcs, which are unintended electrical discharges between two or more conductors. Arcs can occur for various reasons, such as damaged or frayed wiring, loose connections, or faulty appliances. These arcs generate intense heat, which can ignite nearby flammable materials, such as wood, paper, or insulation, leading to a fire. AFCIs use sophisticated technology to distinguish between normal arcs, which occur during the operation of certain devices like motors, and dangerous arcs that indicate a problem. When a dangerous arc is detected, the AFCI trips the circuit, cutting off power and preventing a potential fire. The NEC requires AFCI protection on most branch circuits that supply power to dwelling units, particularly in bedrooms and other living areas. This is because these areas often contain a high concentration of electrical devices and wiring, increasing the risk of arc faults. While AFCIs are highly effective at preventing electrical fires, they do not provide the same level of shock protection as GFCIs. An AFCI is designed to detect arcs, not imbalances in current caused by a person coming into contact with a live wire. Therefore, it is essential to use both GFCI and AFCI protection in appropriate locations to achieve comprehensive electrical safety. In the specific scenario described, the installation of outdoor lights and ceiling fans on a patio requires GFCI protection for the receptacles because this is mandated by the NEC. The purpose of this requirement is to protect individuals from electrical shock while using these outdoor fixtures. Replacing the AFCI breaker with a GFCI breaker will bring the installation into compliance with the code and ensure the safety of users. Furthermore, it's important to understand that using the wrong type of breaker can have serious consequences. An AFCI breaker in place of a GFCI breaker will not provide adequate protection against electrical shock, potentially putting individuals at risk of serious injury or death. Conversely, a GFCI breaker in place of an AFCI breaker may not prevent electrical fires caused by arc faults. Therefore, it is crucial to select the correct type of breaker for each application. When in doubt, consult with a qualified electrician to ensure that the electrical system is properly protected. In addition to understanding the functions of GFCIs and AFCIs, it is also important to be aware of the different types of these devices available. GFCIs are commonly available in three forms: receptacle type, circuit breaker type, and portable type. Receptacle type GFCIs are installed in place of standard electrical outlets and provide protection only for that specific outlet. Circuit breaker type GFCIs are installed in the electrical panel and provide protection for the entire circuit. Portable GFCIs are designed to be plugged into existing outlets and provide temporary GFCI protection for devices plugged into the portable GFCI. AFCIs are typically available as circuit breaker type devices installed in the electrical panel to protect entire branch circuits. When selecting GFCIs and AFCIs, it is important to choose devices that are listed by a recognized testing laboratory such as Underwriters Laboratories or OL. This ensures that the devices have been tested and meet established safety standards. It is also important to select devices that are appropriate for the specific application. For example, when installing a GFCI in a damp or wet location, it is important to choose a device that is rated for wet locations. Furthermore, regular testing of GFCIs and AFCIs is crucial to ensure that they are functioning properly. GFCI should be tested monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. AFCI should also be tested periodically, although the testing procedure may vary depending on the specific device. Consult the manufacturer's instructions for proper testing procedures. Proper installation and maintenance of GFCIs and AFCIs are essential for ensuring their effectiveness. GFCIs should be installed by a qualified electrician in accordance with the NEC and local electrical codes. AFCIs should also be installed by a qualified electrician, and it is important to follow the manufacturer's instructions carefully. In conclusion, understanding the differences between GFCIs and AFCIs and using them appropriately is crucial for ensuring electrical safety. GFCIs protect against electrical shock, while AFCIs protect against electrical fires. Both types of devices are important for creating a safe electrical environment. In the scenario described, replacing the AFCI breaker with a GFCI breaker is necessary to comply with the NEC and ensure the safety of individuals using the outdoor patio. Always consult with a qualified electrician when making electrical installations or modifications to ensure that the work is done safely and in accordance with all applicable codes and regulations. Now let us shift the focus to other protective devices that are often encountered in electrical systems. These devices, such as fuses and surge protective devices, play unique roles in maintaining the integrity and safety of electrical installations. A fuse is a simple yet effective overcurrent protection device. It consists of a metal wire or strip enclosed within a non-combustible housing. The wire or strip is designed to melt and break the circuit if the current exceeds a predetermined level. Fuses are typically used to protect individual circuits or appliances from overloads or short circuits. When an overcurrent condition occurs, the heat generated by the excessive current causes the fuse element to melt, interrupting the flow of electricity and preventing damage to the protected equipment. Fuses are available in a variety of types and sizes, each designed for specific applications. Some common types of fuses include cartridge fuses, plug fuses, and blade fuses. Cartridge fuses are commonly used in industrial and commercial applications, while plug fuses are typically used in residential applications. Blade fuses are often used in automotive applications. It is important to select the correct type and size of fuse for each application to ensure proper protection. Using a fuse with a higher current rating than the circuit is designed for can be dangerous, as it may not provide adequate protection against overloads or short circuits. A surge protective device, or SPD, is designed to protect electrical equipment from voltage surges, also known as transient voltages or spikes. Voltage surges can be caused by a variety of factors, such as lightning strikes, power grid switching, or the operation of heavy electrical equipment. These surges can damage or destroy sensitive electronic devices, such as computers, televisions, and appliances. SPD work by diverting excess voltage away from the protected equipment and safely to ground. They typically contain components such as metal oxide varistors, or MOVs, which are designed to clamp the voltage at a safe level. When a voltage surge occurs, the MOV conducts the excess current to ground, preventing it from reaching the protected equipment. SPD are available in a variety of types and configurations, including whole-house surge protectors, which are installed at the main electrical panel, and point-of-use surge protectors, which are plugged into individual outlets. Whole-house surge protectors provide comprehensive protection for all of the electrical equipment in a building, while point-of-use surge protectors provide localized protection for specific devices. When selecting an SPD, it is important to consider the surge current rating, which indicates the amount of current that the device can safely divert. A higher surge current rating indicates that the device can provide better protection against larger surges. It is also important to choose an SPD that is listed by a recognized testing laboratory, such as UL. In addition to fuses and SPD, there are other types of protective devices that are commonly used in electrical systems. These include ground fault equipment protection devices, or GFEPs, and overcurrent relays. GFEPs are similar to GFCIs, but they are designed to protect equipment rather than people. They detect ground faults and trip the circuit to prevent damage to the equipment. GFEPs are typically used in industrial and commercial applications where equipment damage due to ground faults is a concern. Overcurrent relays are used to protect electrical equipment from overloads and short circuits. They are typically used in large industrial and commercial applications, such as power plants and factories. Overcurrent relays monitor the current flowing through a circuit and trip the circuit if the current exceeds a predetermined level. They can be programmed to trip at different current levels and time delays, allowing for customized protection of electrical equipment. The proper selection, installation, and maintenance of protective devices are essential for ensuring the safety and reliability of electrical systems. It is important to consult with a qualified electrician when selecting and installing protective devices to ensure that they are appropriate for the specific application and that they are installed in accordance with all applicable codes and regulations. Regular inspection and testing of protective devices are also important to ensure that they are functioning properly. Fuses should be inspected periodically for signs of damage or deterioration, and they should be replaced if they are blown or damaged. SPD should be tested periodically to ensure that they are still functioning properly. If an SPD has been subjected to a large surge, it may need to be replaced. In conclusion, protective devices play a crucial role in ensuring the safety and reliability of electrical systems. Fuses provide overcurrent protection, SPD protect against voltage surges, GFEPs protect equipment from ground faults, and overcurrent relays protect equipment from overloads and short circuits. The proper selection, installation, and maintenance of these devices are essential for preventing electrical hazards and ensuring the safe and reliable operation of electrical equipment.